Good afternoon, everyone. I'm Abhay from EDS Technologies, and I thank you all for taking your time out and joining us for our webinar, which we have titled as Applications of GeoVia in Surveying, Mine Planning, and Mine Scheduling. So I would like to begin this webinar by giving a short introduction about our company, EDS Technologies. We are one of the largest technology solutions provider in India with more than 30 years of business transformation experience. We help transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. EDS Technologies has introduced many technologies like 3D printing, VR, digital manufacturing, etc. for the first time to Indian customers and has established itself as a trusted partner for more than 2,000 organizations across various industries, including mining, industrial equipment, automotive, aerospace, and defense. We have a dedicated regional teams reinforced by domain and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. One of them is Dassault Systems, who are our strategic business partners as well. We have a widespread business presence with 11 offices across India, with our headquarters in Bangalore. We are an end-to-end technology solutions provider to our customers. So for today's session, we have two speakers. Our first speaker is Mr. Pramod Sarangi. Mr. Pramod has over 16 years of professional experience in the fields of geology and mine planning in overcast and underground mining, exploration and production planning operations of different mineral commodities. He has more than 11, 12 years experience in customer service, sales, support for GEOVIA solutions like Surpac, and MineSched. He is currently working with EDS Technologies as General Manager Technical with more than 11 years of experience in customer service, sales, and support. He is also a competent trainer of GEOVIA products in the area of geology and mining. Our second speaker for the session is Mr. Arunava Banerjee. So, Mr. Arunava has over more than 12 years of professional experience in the fields of geology and mine planning in both overcast as well as underground mining in different mineral commodities. He is also a competent trainer of GEOVIA products in the areas of geology and mine planning. Currently with EDS Technologies, he is here with for more than 11 years, working with various customers across departments in service, sales, and support, especially for GEOVIA products in India. Over to you, sir.
Yeah, thank you, Abhay, for the setting the context for the webinar. And good afternoon, all. I would like to welcome all the participants for this webinar to discuss and understand the application, how it will be helpful for your geological modeling as well as surveying, resource reserve estimation, and most important thing is the mine planning. That is your mining plan preparation, which will be for your production plan. And you can see that what is the quality, quantity, how you are getting, and how much material you are going to get period wise. So all this information we cover in this particular webinar. And in this particular webinar also, we can also introduce our new application, that is implicit geology modeling, that is called geology modeler. So that also will introduce. So you can understand that how technology is moving forward for the geological aspects of preparation of the geological modeling for the complex deposit as well as the stratified deposit. And as rightly said by Abhay, so if any query or any clarification you require during this presentation, you can just raise your hand and send the questionnaire so that we can address at the end of the particular webinar. And I will now hand over to Arunava so that he will give the full presentation starting from survey, geological modeling, and mine planning, including production scheduling. So, Arunava, over to you. You can start the presentation.
Thank you, sir, and good afternoon, all. So, the first, I'll start from GEOVIA solution. So, in GEOVIA, the brand name of Dassault system. So in Dassault portfolio, there are so many brands are there, not only the GEOVIA, CATIA, SolidWorks, BioVia, Simulia. So one of them is GEOVIA, and in GEOVIA, these are the mining product, the Surpac, MineSched, and third one is the Whittle. So in GEOVIA, we can split in few part, we can segregate. So first is the geology part. Here we can import geological data to create the section, solid model, block model, estimation, then earth design, pit design, dump design, haulage planning, ramp design, and earth resource management means production scheduling from short term to mid term to long term basis. And also in our GEOVIA brand, so urban planning also newly introduced here. So in our GEOVIA portfolio, the first product is the Surpac. Surpac basically used for non-stratified deposit like metal and non-metal deposit, like, and it's covered geology as well as art design part. Next is the MineSched is earth resource management for production scheduling, and third one is the Whittle. Whittle basically used for uh, mine economy purpose, mine economy, so for earth design and earth resource management part. So in mining flow chain or mining portfolio, these are the part: discover, evaluate, establish, extract the material, beneficiate, sell, and rehabilitate. Here Surpac work in that first few parts. MineSched also work in establish and extract portion, means up to scheduling part, and Whittle cover the evaluate, establish, extract, and beneficiate portion. So what is the relation in between Surpac and MineSched? First one is the Surpac. Surpac basically used for stratified, non-stratified deposit like metal and non-metal deposit. And Surpac, through Surpac we can control our survey data. Not only that, geological also, and geological borehole database preparation, solid modeling, resource modeling, then mine design part, pit design, dump design, haul road design, ramp design, and blast design. And then we can start mine scheduling software for scheduling purpose, put the mining rules, put the target, and get the reports with animation. So in mining value chain, through Surpac and MineSched, we can cover everything from survey, drill data, information, database preparation, then block model, solid model, block model, estimation, open pit design, underground design, dump design, blending, and up to the end product. After blending, then target wise, quality quantity wise, we can achieve our targets. In Surpac, first I start the Surpac detail. So first it's split in few parts. First is the fundamental tools in Surpac, and we can import CAD file or SAFE file, or we can digitize several things in Surpac software with coordinate in 3D platform and make DTM digital terrain model. Then import borehole information, scholar, survey, assay, geology, and create this type of needle-like structure. Then geological section, litho-wise or grade-wise, we can create section in any orientation, maybe northern section-wise, north section-wise, east-west section-wise, or oblique section. Then ore body modeling is called solid model. So litho-wise or grade-wise solid model we can create here. Then we can create composite to normalize the sample length and check the basic statistics to cross-check the distribution of the radicals, minimum, maximum, average value, and so many things. After that, we split our solid model in few small parts. It's called block model, and then resource estimation through several methods: inverse distance method, or cleaning method or nearest neighbor method. Then we can create the slice plan. Several type of slice plan we can create, means litho-wise slice plan or grade-wise slice plan or cut-off grade or range-wise slice plan we can create, and then start with design and dump design. This is the workflow of Surpac software. So next, we can import CSV file or a drone data or any type of DGPS data survey file and create this type of CAD-like information and create the DTM file format. Here now Surpac is capable to import point cloud data in several file format, LAS file format or XYZ file format. There are 6 type of file format we can easily import and get the point cloud data. We can edit all those things and reduce the unnecessary points and make the DTM file format. After DTM, digital terrain model, we can calculate the volume in between 2 DTM, cut volume and fill volume we can calculate separately, create sections in any orientation, create contour in any interval, means major contour and minor contour, both contours we can handle simultaneously, wrap image over DTM to give a realistic look. Image means scan data or image data or satellite data or Google Earth image we can easily import here, and intersect DTMs to calculate the volume in between 2 DTMs. This type of operations easily we can handle. Then resource modeling. First we create borehole database using the color, survey, assay, geology, these type of informations. Then validate our data. Then if it is successfully validated, then start the cross section litho wise or grade wise, and then make the solid model, then block model, and then get the resource reporting. In geological database, first we create color data. Here borehole ID, Y, X, Z, northing, easting, RL value, depth and path also should be mentioned here. Then survey, borehole ID, depth, deep of the borehole and azimuth. If it is inclined borehole, the azimuth and deep should be mentioned here. Then assay, it is keep the radical values also. If it is silica, alumina, if it is iron ore deposit, if it is limestone deposit, the radical will be changed. In case of the geology, the L code or lithological description, rock type should be mentioned here. And after import these type of 4 CSV files, then we can create this type of needle-like structure or borehole database. And borehole database management, ore waste classification, it is possible here. Create the composite, create the sections, geological interpretation, high grade sample, low grade samples is the weighted average we can calculate here easily and get the report. Not only that, we can also create graphical logs with plot file. Then basic statistics. After compositing, then we can import those composite file in basic statistics platform to create the histogram, cumulative frequency curve, percentile, QQ plot, means Fe versus silica, silica versus alumina. This type of plot easily we can this type of information we can handle, and we through this basic statistics window we can block model validation, basic statistics calculations, basic statistics reports also we can generate. The number of samples, minimum value, maximum value, mean, median, geostatistical mean, variance, etc. So after database preparation, then we start the digitization of the section. So litho wise, or it is maybe in grade wise with structural information. So one by one sections after digitizations, then we can join each other and create solid model. So it may be in litho wise or it is grade wise. So if you keep your already approved AutoCAD file, in that case we can always import those AutoCAD file in Surpac platform and rotate in 3D, and start solid model directly. No need to digitize the sections. And similar case for section image. If it is in image file format, scan file, we can easily import, rotate in vertical portion vertically in 3D, and then we can start the digitization only ore portion or lithology wise boundary. We can digitize and then create the solid model, block model, and then estimate and calculate the resource report. So up to that level, we can control the explicit modeling. Now we can in Surpac or in GEOVIA platform, we can handle implicit modeling also. So here fully integrated, this implicit modeling or geo modular role fully integrated with 3D experience platform, and fast implicit 3D geological modeling we can prepare quickly and save our time, and display, it will display interpretation, stratified geological model, compositions and rule based classifications easily we can handle here. Grid cell modeling we can easily control here. It is totally is the implicit modeling part. And also we can control the geoscience interpretation and geology modeling part. Here we can see geology modeler part, and it is totally integrated with Surpac software. Is the faster geological modeling, the geoscience data, reduce rework, and collaborate with, engage with team members and stakeholders. Okay. So after implicit modeling or explicit modeling, then start the block modeling part. Here we can split our solid model in few small parts. The small parts or dimension of the blocks is totally dependent on the borehole spacing. It will be 1/3 or 1/4 or 1/5 of the borehole spacing, and we can sub-blocking also possible to for more accuracy purpose, and create the attribute Fe, silica, alumina, 512 attributes we can create in block centroid, and create the constraint below the topography, within the lease boundary, within the below topography and above the ultimate pit. This type of constraint we can easily create to normalize our blocks here, and then estimation our radicals here through inverse distance method or Kriging method or nearest neighbor method, and get the report. So after estimation, we can color our blocks in different way, and lithology wise or grade variation wise, and different type of report we can generate, user defined report, and template we can save for future uses, and lithology wise report, grade wise report, RL wise report, or section wise report also you can generate. So here we can see RL wise, litho wise report, and section wise, litho wise report based on the cutoff grade or grade range wise or lithological wise we can create easily, or we can generate easily here based on our requirement. So after block model estimation and generate the report, then next part is the slice plan, litho wise slice plan or grade wise slice plan which you can easily create RL wise, and then you can start pit design. In pit design based on the slice plan, ore portion, dump design, dam design, ramp design, switchback, 180-degree rotation of the road within the pit is called switchback. Easily we can handle all those things, and volume calculation within the pit. So within the pit, below the topography and within the pit, we can calculate the reserve reporting, and here also we can define user defined report, save the templates for future, bench wise, litho wise we can create the report, bench wise, grade wise also we can generate this type of report. And then come to output. So surface plan plotting, with borehole, section, lease boundary, safety zone boundary, contours, bench toe, bench crest, and surface outcrop. Also, we can identify in the plot file. Borehole log plot. Individual borehole you can plot separately. Section, several sections we can plot in single sheet. In slice plan with all the requirement, means grade wise slice plan or litho wise slice plan, easily you can plot in different paper size. So this is the interface of the Surpac software. So here we can control several files and several section planes also we can save for future. And in user graphics interface, we can split in several parts to control several data at a time. So next, production scheduling is the GEOVIA MineSched. This is another product. After Surpac, we can use this product for scheduling purpose. So here, generate plans in schedules, achieve target in terms of grade and tonnage, generate report, period-wise grade and tonnage. So data format, several data we can import in this mine scheduling software. Surpac block model data, not only that, data mine data, James, Vulcan, Whittle, Minex, CSV files also we can import, and string file format or polygon. And import informations like surface, current surface is very important with other topographical information, ultimate pit limit, then validate block model with all attributes, mining constraint below the topography, above the ultimate pit limit. These blocks are very important for further scheduling. Material class definitions, grade wise or litho wise, you should classify your block model first, then only you can start the mine scheduling software. Then we can identify or we can import several type of polygon for selective mining. And available resource capacity is very important. Per day wise, your capability or resource capacity, it should be mentioned here. And the target, quality, quantity, you should mention. Suppose 2 million ton in a year, and your quality will be 62% of Fe value, and silica is less than 2.5%. This type of quality and quantity should be mentioned in mine scheduling software. And scheduling period, monthly or quarterly, half yearly, yearly, or 5-yearly, you can run the scheduling up to end of life of mines. In short term to mid term to long term, you can run this scheduling. So this is the interface of the mine scheduling software. So here we can import the block model and several type of data set we can import here, and define the material class, quality, and then run the software. So in mine scheduling software, there are 4 simple steps are here. One is the define geology. In define geology, you can import block model or other informations, block model related, suppose specific gravity, grade range, then quality of the material. Then put the setup schedule. Here we can put the pit location, how many stockpiles are there, dump information, then plant information or dispatch location, required grade, and how many benches we can mine at a time, how many locations we can handle, then our blending proportion, targets, grade, and calendar also, and then jump to create scheduling. In create schedule, we can define the period first. If it is short-term scheduling, then monthly we can run here. If it is long-term scheduling or up to end of life of mines, then yearly or 5-yearly, we can set the time limit and then get the ultimate output in report format, in graph format, and in animation file format. And ultimately, published result we can generate different type of Excel sheet we can generate here. Not only that, we can update our Surpac block model. So here in surface mine scheduling, we can control at a time multi-mines in mine scheduling software. The mine scheduling software is totally rule-based software. Put the targets. It is using for long to short terms. Material movement is very important from one location to another location. College calculation, graphical output, the animations is, you can see the animation, and different type of reports and histograms we can generate. So the benefit of the surface mine scheduling or MineSched, one is that it is long term to short term for open pit or underground mining. Not only there, strip mining also possible here. Prepare practical scheduling quickly. Then different type of activities we can introduce here for short term scheduling, like a haulage, drilling, charging, blasting to calculate the actual delay. Not only that, quality control, targeting grade, advanced blending strategy we can control here, confidence in result delivered, etc. Then in define geology, we can import the block model, cross check the block model, it is anything is wrong or not. If it is okay, then we can proceed further. And if it is anything calculation is missing, expression is missing, we can easily calculate here. Suppose LSF for limestone, lime saturation factor, this radical or this attribute is missing in our block model, so we can easily calculate in MineSched software. Then validate your data, and if anything is wrong, so auto check for errors option. Through these options we can see the actual error and we can rectify in block model and refresh all those things in this platform. For short-term scheduling, here we can introduce the drilling, blasting, and then start the mining activities. These drilling, blasting, and activities, these basically used for short-term scheduling, monthly basis or quarterly basis. And complex material movement we can control easily. Multi-mine location and material movement we can handle. We can handle several stockpile, and we can dispatch locations. We can set one point, and then we can control our ultimate targets quality and quantity wise. And not only that, we can handle the dump locations also, means scheduling, dump scheduling, it is possible here. So there are two type of dump scheduling we can handle in MineSched software, was the in-pit dumping and spit dumping. So in blending strategy is very positive side in MineSched software is the production blending capability. It is good strategic software for this, and stockpile strategies result in high quality material to the plant after blending. And this type of report we can generate. The interface of the MineSched software after create scheduling, and we can easily visualize the material volume, tonnage, grade in different mining location. So this is a mining MineSched scenario 1. So here we can see MineSched happen in a mining location, and simultaneously dump scheduling also working, dump scheduling, in-pit dumping or spit dumping. And not only that, stockpiles is controlled monthly after blending strategy. Here strip mining also possible here to meet our target. Strip mining, it is basically used for limestone deposit or in to surface subsurface deposit through surface miner. And then through scheduling software, we can yearly production plan and report we can generate easily. The first year production plan with dump area, first year dump. The second year production plan and DTM with second year dump will increase in certain direction because it's totally hilly terrain with report. Third year production plan and DTM with third year dump. The fourth year fifth year, and then we can see the yearly growth of a dump first year, second year, third year, fourth year, and fifth year. And this is the production plan in plot file format. Not only that, in the after create scheduling, then we can this type of histograms we can easily generate and stack bar with lines. So we can see the production, it will vary, or stripping ratio, it will go within a control or not. And this type of current pit and monthly pit we can generate, means short term seedling. There are 2-3 locations we can active in a month, so with stockpiles location, so we can this type of plot file we can create here. And finally, after production scheduling up to end of life of mines, then we can update our block model with new attribute. So after that we can open this block model in Surpac software, and then we can cross check. So how many blocks are mined in first year, then second year, third year, cross check the volumes, cross check the position also. If it is you are not satisfied with that, then again we can open the MineSched software, change the direction, change the parameter, change the bench number, and then create another scenario. So several scenarios you can generate simultaneously, and then you can choose best one for your operation purpose or for your report purpose or seedling purpose.
So I would like to thank Pramod sir and Arunava as well for delivering this very informative session. I'm confident that it was helpful to our audience as well. I would like to also thank the audience for taking their time out and joining us for this session. If you have any further queries related to the subject matter or any other requirements with respect to mining or geology, you can always connect with us. Our details are displayed on the screen right now. You can reach out to us at any time and we'll be happy to address your queries. Please do keep an eye out for our upcoming seminars and webinars and other sessions. You can follow us on our social media for the same. Thank you once again for joining us today. See you at the next session.